Hello everyone, welcome back to my channel. My name is Kabil. In this Amazon EKS series, we are going to build a Kubernetes environment on AWS while understanding the concept behind every step. I have divided this series into two playlists. The first playlist, we will configure OpenID Connect and IAM role for service account. Install the AWS Load Balancer controller, expose our application using the Gateway API approach. The second playlist, we will use EKS pod identity. Install the AWS Load Balancer controller again using the latest authentication method and expose our application using the traditional ingress approach. Throughout the series, I will explain why each component is required, how it works internally, and where it's used in real production environments. I have already completed the prerequisites like configuring the AWS CLI, installing kubectl, and Helm. So we will start directly with Amazon EKS cluster setup. So without wasting any time, let's get started. Let me start creating the cluster, understand the IAM roles required for the cluster as well as the worker nodes so that we can validate the cluster is active and healthy. I'm going with custom configuration. I'm naming my cluster as learn with Kabil-EKS. And we need to make sure to select the IAM role for this cluster. By default, AWS provides the role name and we need to validate this role is associated with the default policy as EKS cluster policy and create the role and let the other settings be default. Click on next. If you have your VPC setup, you can choose yours, otherwise you can go with default. I am choosing my VPC setup and let the other settings be default and click on next. I am leaving this unselected. Why? Because I'm configuring the monitoring stack in my EKS cluster setup, which is Prometheus and Grafana. So I'm not enabling any of the observability metrics here. So I'm skipping this. We need to select few add-ons here. The major ones are kubeproxy, VPC CNI, and core DNS. But for this cluster setup now, I'm choosing only two so that we will later understand about VPC CNI and EBS CSI Driver add-ons and all. Choosing these two add-ons, kubeproxy and core DNS, and selecting everything. If you see now, it is recommending EKS pod identity agent. Why? Because by default, AWS recommends to go with EKS pod identity agent. When compared to OpenID Connect and IRSA setup, EKS pod identity is very easy and comfortable. We will understand in our second playlist. For now, we will go with OpenID Connect and ARSA model only. Click on next and create the cluster. It will take almost 10 to 15 minutes to create the cluster. If you see now, cluster is in active state. It almost took 10 minutes to create the cluster and get into active state. So once the cluster is active state, we need to validate via our AWS CLI. Let me switch to my other window. Check for any existing cluster in our AWS account. This is the command we use to check for any existing clusters in our account or not. You can see our cluster is active. Let me update my kubeconfig file using the command AWS This command will update our kubeconfig file so that we can reach our clusters. Let me check my available cluster context. AWS get-context. If you see now, there are two contexts available in my config file. One is local, which I configured via kind setup. Another one is our EKS. It is chosen as a default one, so I'm checking how many namespaces are created in our EKS cluster. kubectl get namespace. Let me check for any active ports in our cluster, all the namespaces. I can see only two ports, which is pending state. Why? Because we need to configure the networking first for this core DNS ports to be active and ready state. For that, we need to enable the VPC CNA add-on. Before enabling the VPC CNA add-on, we need to configure our OpenID Connect and IRSA setup for that. Let me do that now. If you know one thing, I haven't created the worker nodes now. Why? Because we need to first enable the add-on of this VPC CNA so that the networking model will be configured so that these nodes will get aligned within the cluster itself. So let me create the add-on first. Click on get more add-ons and search for the VPC CNA one. Here is the add-on. Click on next, and we need to make sure we need to choose the IAM role for service account for this project, this playlist one. Here we need to create the new role. Define, let the role name be EKS-role. Remove everything after this EKS-role, and we need to define the parameters. For defining the parameters, we need to give these three values: OpenID, connect ID number, and the namespaces and service account name. For OpenID connect ID, we need to get that via from our EKS cluster. Here you can find the ID value. Under this OpenID connector provider URL, you can find the ID. Just copy it, paste it here, and the namespace will be cube-system. And the service account name be AWS-node. And check the trust policy, and the service account name what we given. Click on save, and we need to attach the policy to this role. We need to choose existing policy, search for CNI, enable this policy to this role and create the role, and click on next, create. If you refresh now, will be showing in active state. Yeah, once it's in active state, we need to create the identity provider in our IAM portal. Let's click on IAM. Under the IAM, click on identity providers, add the provider, choose the OpenID connect, and edit the URL. Just copy this URL and paste it here. And the audience name will be sts. is on aws.com. And add the provider. Once the identity provider is uh, added and in active state, we need to create now the worker nodes under EKS cluster. Switch to EKS cluster. Under compute section, add the node group. Here we need to name our node as anything we want. I'm naming it as workers. And I'm giving the node IAM role as EKS node role, which by default AWS will provide this role name, and it will attach the below policies to that particular role. Just create the role and click on next, and let the other node images and types be default. Click on next. For this node group network configuration, I am choosing only the public subnets. Why? Because I want to access these worker nodes. So I am enabling the remote access as well. So private subnets, I'm not, I don't need this now, so that the endpoints will be accessible. So configure the remote access. And if you have any additional security groups, you can add it here as well. I have one, but I'm not going to add it now. So let's go with next. Okay, I forgot to add the key pair. Let me choose the key pair which I have already. Let me choose the security group now. Click on create. It will take around 5 minutes to create the worker nodes. If you see now, the worker nodes are active and ready state. Let me check in our terminal. We'll get nodes. Yeah, these nodes are visible. Check for any active pods in all the namespaces in our cluster. If you see now, earlier code DNS is the only pod which was in pending state. Now, if you see below, pods are active and running state. Once we configure the VPC CNA add-on or the plugins. Once this has been configured, it will enable the networking between the pods and make them active state. If you ask me about what is OpenID Connect and IRSA, I can inform you like OpenID Connect is an identity provider that allows your EKS cluster to establish a trusted relationship with the AWS IAM roles. It's like a identity code verification system. Like, and what if you ask me about what is IRSA? IRSA is an IAM role for service account. It's a feature that lets you assign an IAM role directly to the Kubernetes service account instead of giving the AWS permission to an entire EC2 worker nodes. You grant permission only to the pods that need them. Okay. Let me show you the service account which we created. kubectl. If you see now, the service account which we created through the role for that VPC CNA is visible in our cluster because of the OpenID Connect provider setup only. Okay. After configuring this and all, we need to enable the other add-on called EBS CSI Driver, which is required for our project because in my earlier project, I configured the local path retain using the provisioner like rancher, rancher model. But for now, we are using the EBS driver so that our persistence volume will dynamically provision through the EBS setup model. Okay. Let me enable the EBS driver and provide the IAM role for that service account as well, similar to the VPC CNA model. Let me start adding the add-on EBS CSI driver. Get more add-ons. Here is the add-on. Click on next. Choose the IAM role for service account. Create a new role and name the new role as EKS-PS role and define the parameters similar to our existing DNA role. Hyphen. Open ID value will be this. Copy paste the ID and the service account name will be the EBS-CSI-controller-SA. Just check the service account name will populated correctly and click on the policy and the policy name as SI driver policy 2. Click on this policy and create the role and click on next. Create. It refresh. It's creating. Currently the driver add-on in EBS driver add-on is in active state. Just verify in our terminal for any ports for this particular driver is added or not. If you see now, we have EBS CSI controller ports and the nodes are added here. Once it's configured, we can start enabling means we can start installing the ALB setup and gateway setup and currently we don't have any gateway resources added like under any gateway provisions features are not in our cluster. We can validate via this command kubectl API-resource. HTTP route. If you see, there are no gateway resources, nothing in our cluster. We need to configure this by installing this manifest file. If you check now, we can see the features are added to our existing cluster. Gateway classes, gateways, HTTP routes. These three are required now for our playlist one. Before that, let's verify the CSI drivers are available or not. This is the one we configured. It's there. So yeah, for our project, for as inform for the EBS provisioning setup, I am using the retain policy. So I am enabling that provisioner, I mean, through the manifest file which I created. Okay, I have enabled the means I am using the reclaim policy as a retain. So I'm going with this manifest files kubectl. Let me verify for any existing storage classes are present or not. Uh, Existing one is with default, I mean default one is delete. I created the retain reclaim policy with retain reclaim policy. Okay. After creating the storage class, let me start configuring the AWS load balancer controller, similar to what we configured for the add-ons, VPC CNA as well as the EBS CSI driver add-ons. We configured the role sections first. Similarly, we configured the role section for this load balancer controller as well. Just switch back to the AWS console. Click on IAMs. Under IAM, click on roles. Under role section, click on create. Go with custom trust policy. I have my JSON file already created. Just need to modify the ID sections to that of the EKS cluster. Copy paste and modify only the ID parameters. Copy the IDs, paste it here. Okay. And there is one more area as well. We need to provide the ID. Okay. Once provided the IDs, just click on next. We need to add the policies to this particular role as well. Create inline policy. I have the policy file opened already. Just copy the entire JSON file and add it here. I will add this in my GitHub repository so that you can refer them while creating the clusters from your side as well. Click on next. Under the role name, we need to provide the role name as EKS-load balancer. and create the role. Yeah, once the role is created, just verify the service account's name is correct or not. AWS Development Controller. Yeah, just verify the same service account is present inside the cluster or not. Okay, switch back to the terminal. kubectl get service account hyphen n setup. Okay, it won't be visible. Why? Because for load balancer controller setup, this one is not managed by the AWS section. In AWS service itself, we are configuring this manual and installing them through the Helm setup, Helm deployments here. Earlier, if you go check with VPC CNA as well as the EBS driver model, they all are configured via the add-on, so it was managed by the AWS service itself. But this time we are configuring it manually, so we need to configure this service account through the manifest file. Okay, let me show you how to do that. I already have the manifest file created for this service account. Okay, only we need to modify the roles name because I created it with different role name. Only we need to edit it here. And let me edit the service account YAML file. Replace only the role name. The role name which we configured is EKS hyphen load balancer. Okay. Just save the file and apply it. kubectl apply. Just describe the service account. Describe. Okay. If you see now, the service account is created under the namespace cube system. Let me start deploying the AWS load balancer controller through the Helm nodes. Okay. This is the command that we need to use to install the load balancer controller. But before that, we need to add the repository. I added already in my environment that you need to add for yours as well. I will provide this in the GitHub page. Okay, you can just verify how to add the repository and all. If you see now, this controller is deployed successfully. Let me verify the ports which what and all created under this. Okay, kubectl get ports kube hyphen system is the namespace which we deployed this load balancer. Okay, Currently this and all in active and running status. Okay. Before deploying the applications, I need to label my worker nodes so that the workloads will uh, configure only on the labeled workers. Okay. Let me apply the labels first. kubectl get nodes. kubectl I am naming them both nodes as application true because I want in the both worker nodes the Flask application to be deployed. Okay. I not only we need to label, we also need to edit the manifest file as well to pick and to make the node selectors and all. Okay. Other than that, we need to also label the nodes as one as monitoring, as other one as database, so that one node by default will be fixed for database services, and another one will be used for monitoring purpose for deploying the monitoring stack like Prometheus and Grafana. So let me label the one node as role equal to database, and the other node as monitoring. Okay, role equal to monitoring. Okay, once the nodes are labeled, we can configure the infra resources like gateway classes and gateways. I believe which I already applied. Let me verify whether it's deployed. I mean, it's applied or not. kubectl get. Okay, I think I haven't applied the gateway classes before and all. Okay. Let me start applying now. kubectl apply conf gatewayclass.yaml and kubectl apply conf uh, load balancer as well. We need to configure here. Okay. Okay, namespace portfolio not found. Yeah, I labeled the only the nodes. I think I haven't created any namespaces first. Let me verify kubectl get namespace. Okay, only I can see these namespaces. Let me create the namespaces of kubectl create namespace portfolio. So that I do I am why we need to create the namespaces because we want to isolate each services from one namespace from the other. I don't want to clutter all the services, I mean applications pods in one of the one namespace itself. I want to create other namespaces monitoring as well for deploying my monitoring stack. Okay, after that, let me apply the load balancer configuration as well. Afterwards, deploy the gateway here, and I'm routing the traffic via. I'm routing the traffic via host route here, not path-based routing, host-based routing. So HTTP manifest file I'm using here with host-based. Okay, kubectl apply. Make sure I haven't deployed my application yet, so we can configure this later as well. Okay, let me deploy my application first. In the meantime, you can validate any gateway classes are created or not. Yeah, created and accepted is true. Let's create for check for gateway. Okay, gateway I deployed on namespace portfolio. Yeah, it's deployed. Okay, let me deploy my application using the Helm charts. Let me switch back. Helm install portfolio under the namespace portfolio. If you see now, my portfolio application is deployed, and let me deploy my monitoring stack as well. I have already added the monitoring stack under my repository and all. So I just need to deploy them through the Helm charts. Okay, Helm install monitoring hyphen namespace under monitoring namespace. I have my monitoring values file, which is customized one. And I need to mention the repository for that .yaml files. This Prometheus hyphen community hyphen cube hyphen Prometheus. Yeah, Prometheus stack. If you see now, my monitoring stack is also deployed. Let me copy paste the Grafana password. Okay. This is the password. Okay. Let me validate the pods and application is active. kubectl get pods under the namespace portfolio. Okay, everything is under running state. Okay, and I use the MySQL init as a job manifest file. Yeah. Let me check for monitoring as well. Under monitoring, all the pods are active running status only. Okay. Just verify the service section for all the namespaces. Okay. MySQL service is a headless service, so it will be with no IP. Flask service IP is there. Okay. You notice all the service type is of cluster IP. We haven't exposed this to node port or load balancer type. Okay, that's how production setup will be using most of the industries and all. So yeah, let me validate the uh, load balancer. I mean, like HTTP routes which we deployed. We need to check for particular namespace. I think I deployed. Okay, I haven't deployed the routes, right? Okay, let me deploy them. Once deployed the application, only I plan to deploy the routing and also. Oops, apply hyphen. I'm deploying them all through host-based routing methods, not path-based. Okay. And let me check for the routes now. Okay, under portfolio, learn with kabil.in is the host name. Under monitoring, if you check, there will be two, one for Grafana and another one for Prometheus. The Prometheus is also picking learn with kabil.in. I think we need to modify this to yes. So it is picking in. It is given currently Prometheus.learn with kabil.in, but giving learn with kabil.in. Let me modify one more time. Okay, I think need to check the monitorings okay, the Prometheus URL which defined here all everything looks good only. Let me check. Under info resources. Okay, I applied Prometheus hyphen route, not host. Okay, that is the issue. Let me delete this. Apply this manifest file. This one is the host based routing. Okay, the earlier one which I applied was path based, so that's why the HTTP route was not reflecting correctly. Check now. Okay, couldn't. Okay, yeah, now the host names are reflecting correctly. There is some issue I'm getting. Let me verify one more time. And okay, now there are no warnings available, right? Okay. And let me check ETL get load balancer configuration. We deploy already. Let's verify. Okay, under the namespace portfolio, it's deployed. Check the gateway. Okay, the address is not populated yet. I think I missed to deploy one more. Okay, the target group I haven't deployed yet. Yeah, need to deploy the target group as well so that it will be of type IP based routing will be applied. Let me apply this setup as a kubectl by this portfolio hyphen target group. Let me monitor real time with watch parameter. Okay, if you see now, the address section is populated now. Okay, let's go back to the console and verify the dashboard under EC2 instances for load balancer setup is visible or not. Click on EC2 instances. Yeah, if you see now, load balancer is 1% and volumes, if you see, 3 is there. Why? Because we configured the EBS CSI driver, which will create dynamically the PV models based on the volume claim templates which I defined in the MySQL stateful set status means MySQL stateful set file, okay, which is 1 GB. Is picking this one. This one is of a retain claim policy, so it won't delete no matter what, even if we delete the worker nodes and all. And if you go back to the load balancer, you can see the load balancer configuration name as well as the listeners configuration rules and all, which I enabled for 80 as well as 443. I also configured the SSL certificate for my application, which is learn with kabil.in. We can validate before modifying the DNS records and all. Okay, just do a curl test, curl hyphen header. The host is learn with kabil.in and URL is HTTP. Okay, let me reshare my VM inside terminal. Yeah, if you see now, I can access my application with the header learn with kabil.in. Why with the header like this it will be visible is based on the HTTP routes which I configured. If you see my portfolio route, I configured it via with the host name learn with kabil.in. Learn with kabil.in, so that we need to make sure the header will be with learn with kabil.in to the DNS name provided by the load balancer and all. Okay. We can also modify the DNS records so that we can access it in the internet from the internet and all. Okay, let me modify that as well. Okay, let me switch to my uh, browser. Let me switch back to my provider. Like my provider is Namecheap, where I purchased the domain. Let me create my existing records. We refresh, login again. Uh, Clear the existing records. Create the new record. I am choosing the alias record here so that the DNS name will get mapped automatically. So the backend, because the backend ports will get uh, and the backend port names will get renamed and the IPs will get changed frequently once the ports went into and delete and recreate status. So it's always recommended to use the DNS name and the two with the alias record type. Okay, we can create, add the new record as well. The C name for Grafana as well. Create it. It will take some time to start resolving to this new addresses and all. So let's wait for some more time. Let me start checking the browser whether it is resolving correctly or not. Learn with kabil.in. Yeah, it's currently resolving to the present application which we deployed to the EKS. This is the application which I developed through Python, Flask frameworks and all. So yeah, let's go to the about me section and verify. This one is an interactive, like this will store the data in the backend, like to the databases like MySQL DB, which I used. If you want to share your details, you can just click on X, yes, and provide your name and something. Like if you want to provide your detail like username, you can provide yours as like mine. And on submit, yeah, you have submitted the records. If I want to view how many people visited the sites and the details about this, and I will do it from my side, the backend. Okay. I also configured the API request, which I can do it in the browser. But for now, I'm not going to expose the API setups and that. So yeah, uh, let me open the Grafana portal as well. Grafana.learnwithkabil.in. Okay, this one is not a secured one because when I purchased the domain, I haven't enabled the wild card so that subdomains would be populated with it's not assigned with SSL and all, so it will be with HTTP only. Provide the credentials admin and the password which I got from the terminal. Okay, we can check the cluster status and the utilizations and all. Yeah, if you see now, this one is of the node 1 and another one is the node 2. Yeah, these are all configured via the Prometheus. Okay, Prometheus metrics. Okay, let me show you like how I will validate the visitors count to my applications and all. Just click on add connection, add the MySQL, add new data source, and this will be of the service name MySQL-service. Dot the namespace will be portfolio dot svc hyphen svc dot cluster dot local colon 3306. Database name will be self underscore site, and I am providing authentication. If you want, you can add this parameter of modifying it to IST timings. Okay, database connection is okay now. Just save and test. Build a dashboard. The panel. Name it as anything you want. I am naming it as visit counts. Watch parameters, some values. I'm picking the data source as MySQL, and I'm adding the MySQL code here for visualization, like collecting only those uh, uh, metrics. Yeah, if you see now, I can monitor it real time, like how many people visited my application. Like if you are in my home page, if you refresh, it will increase 6 currently. If I do increase, I mean refresh, it will back to 7. Similarly, like how many people submitted the customer details, I can view. How many people visited about me sections that I can see. A project sections also I can monitor real time. This is how we need to configure for our setup. Also, we can do configure the alerting as well, which we will discuss on later stage. Okay. And if you want to update any changes to your existing application setup, like for example, under my project section, I completed this project now current, right? If I want to add this as a sixth point, I can do it lively. No need to bring the application down and uh, add the Docker images and publish it to the Docker registries, and then then deploy the application. No need to do that, and then only we can do it real time. I'll using That's the beauty about the Kubernetes setup and all. If you want, I can show you that one as well, like how we can do it real time. Okay. Let me switch back to my editor. Okay. Let me get to my. Okay, this is my application setup. Yeah, under the MySQL seed config map file. Yeah, this one is the schema config map manifest file, which we are not going to do anything. This one is a schema setup. Seed is the major setup we need to add here. Okay, let me add the sixth parameter. sixth point. EKS setup. Just naming it randomly. Okay, EKS setup and deploy. It is populated. Just give a random name. There is no URL present with this name. So if you want, you can limit this to till Kabil Karti. Just save it. After saving this, what we need to do is we need to redeploy our portfolio application using the Helm charts. Okay, let me do that. Let me switch back to my terminal. Helm is go back. Helm install portfolio namespace portfolio. Dot okay. If you want to monitor it real time of the changes, you can do it. Kubectl get ports portfolio. Okay. Currently, these are our existing setup which is in running state. Let me deploy my new setup. Okay. After modifying the project section. Okay. You can check here itself real time. So there is some failure happened. Installation we cannot reuse a name that is still in use. Okay, sorry. Instead of install, we need to use upgrade. Helm upgrade. Yeah, if you see now, my init job, new init job got initiated and it got completed. Let me check in the applications page. Let me refresh. Many people visited on day. So let me back to my browser. So yeah, let me refresh. Okay. It's not populated. Let me verify by going back to the home and see. Still, it's not populated. Let me check why. Okay, I think I mentioned the command here. Let me switch back to my VS Code editor. Okay, I just corrected it. Let me validate real time in the job section as well for any errors it having or not. Oopsie. There was an error, that's why it's not updated clearly. Interface syntax error. Check the manual. Line 39. I know it's because of the comma which I missed here. Once adding the next point, we need to make sure it's populated and it's funded with commas and okay. Just save it and upgrade once more. Upgrade portfolio. Okay, it's completed now. Let me verify this particular jobs that it successfully ran or not. Okay, everything ran successfully. So let me verify this time. Let me switch back to my browser. Let me it refresh. Yeah, if you see now, this section point in this project section with the extra point is added. There is no downtime happened at all. So that's the beauty of this EKS clusters and all. And but compared to the complexity of other clusters like Docker Swarm Setup, Docker Swarm Setup and all, this one is having extra functionalities and features. So that's why Kubernetes is used widely compared to other clusters and all. So yeah, once you have some basic understanding of how each Kubernetes components behaves and some hands-on practice, you can do some projects of your own applications and all. Currently, I have completed the playlist one using the OpenID Connect with IAM role for service account. And for the second playlist, we will start using Amazon recommended authentication model using the EKS pod identity, which is very easier compared to this OpenID Connect model and all. You will get to know like which one is easy and all. You will probably choose the later one only. So yeah, uh, thanks for watching. Bye.